HVAC 360, episode number 23. HVAC at the University. Hey, welcome back, everybody, to another episode of HVAC 360. I'm your host, Matt Nelson. This week, I'm going to be talking with a professor of architectural engineering at Penn State University. His name is Bill Bahnfleth, and he is an ASHRAE Fellow, among other things, professional engineer. But he's a professor at Penn State and also a director of the Indoor Environment Center. So, really, I think what I want to talk about in this episode is some of the different degrees you can get. If you're interested in being an engineer and you're looking for schools and you may not necessarily know, okay, do I go in this direction? Do I become a mechanical engineer? There's what's called a mechanical engineering technology, which is kind of more of a hands-on engineer, or there's an architectural engineering, and Bill is actually kind of a specialist in that area of focus. So that's why I wanted to talk to him. He kind of gets the whole breadth of the HVAC degrees, so to speak. But that's pretty much all I have to say, and I hope you enjoy the interview with Bill. So let's go to the tape. All right, welcome everybody. Today we're going to be talking to Professor Bill Bahnfleth, and he is the professor of architectural engineering at Penn State, and he is also the director of the Indoor Environmental Center. Welcome, Bill. How are you doing?
Very well. Glad to be here.
All right, so Bill, tell me a little bit about your background.
Educationally, I'm a mechanical engineer, have bachelor's, master's, and PhD from University of Illinois, and professionally, I've worked as a researcher for a U.S. Army Corps of Engineers laboratory that's in Champaign, Illinois, near the U of I, and have also worked a number of years as a consulting engineer in Cincinnati, Ohio, a firm called ZBA, and came from there to Penn State in 1994 and have been here ever since on the architectural engineering faculty. I've got a PE, and I spend a lot of my spare time doing ASHRAE activities.
Yes, I noticed that you are a ASHRAE Fellow, so that's pretty exciting. Now,
yeah, that's a great distinction.
Now, at what point did you getting into engineering? What point did you want to get into engineering yourself?
Well, the decision to go into engineering, of course, was one that I made in high school. I can't say I was positive at that time that it was the right one because I had lots of interests and options, but I grew up with a father who was an engineer in this business, and so I had him as an example and a role model, and I decided engineering looked like it would be a good direction to try, and so that's what I did. It took me a long time, however, to come around to HVAC and to architectural engineering. I really didn't go that way educationally until I was in graduate school.
Now, I guess, how does, going from the consulting world into a professorship, what kind of made you want to make that transition?
Well, I suppose anyone who gets a PhD has thought at some time about wanting to teach and to do research, and I was actually happy as a consulting engineer, but I got a call from a colleague here, Stan Muma, who was also a University of Illinois graduate, about a position that was open, and architectural engineering sounded like the kind of academic job I might like, and so I gave it a shot and switched careers at age 37, and it's been probably the best decision I ever made.
So now, I guess getting into kind of the holistic, the whole kind of topic that we want to talk about, being, HVAC at a university. What do you think, at that young age in the high school? What do you think makes, a good engineer? What, is somebody going to be, pre-inclined to be an engineer, or is it something that they can just decide to do and go after it if they're really passionate about it?
Well, I think that there are lots of students at high school age who have the ability to go into engineering or a technical career. I think the big issue is how well are we preparing students in high school to go on to a university education in engineering. You have to start building the foundation of analytical skills, mathematics, and science at a pretty early point in order to be in a position to go into an engineering curriculum.
Now, are there any attributes that people kind of miss? I mean, if you hit on the basics, if you're going to talk to a engineering student or somebody who wants to be an engineer, or who thinks he wants to be an engineer, you're going to highlight the fact that, hey, you should be good in math, or you should have an interest at least in math and science as well. What sort of things that people often miss, you think, contribute to making a good engineer?
I think the thing that's probably overlooked sometimes is the importance of communication skills, both written and verbal, and of interpersonal skills. You know the joke about an extroverted engineer being someone who looks at your shoes when he talks to you. I think that you find out when you go into practice that at least 50% of it is communicating effectively in both writing and in person-to-person sort of situations.
So when you have that interest and you're looking for a good school, what are some of the things that you should look for when you're looking to find a good engineering school?
Certainly, you want to make sure that it's an accredited school. That kind of goes without saying. Certain schools by reputation that they place their graduates into good positions, so it's kind of outcomes based. If you know that a school has a record of success in careers, that's something you would look for. And I think you just generally want to look for an environment that's going to give you a strong foundation on which you can build. It would be nice if you knew exactly what your career was going to be, but most students who go into engineering probably don't really know exactly what career they want, and you have to be in an environment where you can figure that out over the course of 4 or 5 years.
Now, obviously, you've struck on the idea of the ABET accredited school. That obviously that it meets certain criteria for being accredited engineering program. What, I guess, are there schools out there that are not accredited, and what's the primary difference that they've gone through?
Well, I couldn't, off the top of my head, name schools that aren't accredited, but accreditation is important because it is an independent verification that your program is adhering to some generally accepted principles of what should be taught in the curriculum, who should teach it, and how the program's quality should be monitored. So it's important, and I don't think you can be very successful as an academic institution without accreditation.
Okay, fair enough. Now, and I think that I just pause because we do have some international listeners. Obviously, this is a kind of a U.S. Based discussion, but I think there's some valid points here. All across the board that you need to kind of adapt to your specific environment. So, whether there's a governmental accreditation of a certain university that you want to attend, to make that career path possible, you want to make sure that you check that out and do your proper, fact checking before committing to that university.
That's certainly true, and well, you know, though, that there is international accreditation through ABET, or substantial equivalency. So
Okay.
I think there's a movement on to establish more uniform accreditation standards worldwide.
Now, on the topic, obviously people when students are looking for schools, they're looking for, okay, does it have the right kind of programs do I want? Really, is it going to provide the kind of social environment or specific things that kids of that age are really going to look for? It has to be kind of is there the right fit, so to speak? Now, another thing, obviously, financially. Scholarships. What can students kind of look at as far as scholarships go when they're looking for engineering schools? Are there scholarships specifically geared for engineering schools?
Well, there's financial aid in various forms available to almost anyone who applies. A lot of them are based on needs, so you have to submit some summary of the family's financial position, their ability to pay, and that can result in either outright grants or, in many cases, low interest or deferred loans. That's the major way. There are some specific scholarships that support particular curricula. For example, ASHRAE offers a lot of scholarships to students who are in HVAC and R programs, but really, the cost of education has become a serious issue, and I think a lot of people have to look at the cost-benefit of university education when it gets to be $30,000 or $40,000 a year, even for a public school.
Now, do you see that being a problem going forward? Is this a major hurdle of the amount of engineer? We've always in the U.S. there's been a great push, or at least a perceived need, that we need to produce more qualified engineers. Do you think that's going to be a problem going forward with the escalating costs of education?
I don't think that cost is a factor for producing more engineers any more than it is for any other curriculum, because at least there's a demand for graduates and good pay if you get into engineering. I think the problem of engineering supply is more related to what happens down in the high school and earlier years, and what we're doing with STEM education. I think there's a perception that we really are not preparing students at that level properly to go into technical careers, and that we aren't getting them interested. So a lot of organizations like ASHRAE are putting a lot of effort into reaching that particular audience, and not just focusing on college students anymore.
Mm-hmm. Oh, absolutely. One note that I'll say on scholarships, I'll just throw this in there. Obviously, if you're looking for scholarships that are not, university centered, I would consider, obviously, other industries or associations, I'll say, organizations that are affiliated with the type of engineer that you want to be, whether it be the ASHRAE, like you had mentioned, or there's ASPE out there, the American Society of Professional Engineers. I'm sure that they probably have some scholarships. Even there might be even a distinction. I know ASHRAE offers them nationally on a society level, but obviously there's a need locally that we want to be able to support on a local level. I know the local chapter here in Cleveland does support engineering students that want to go into the HVAC field. Also, I know that even, for example, NAWIC, the National Association of Women in Construction, they will support students going into the engineering curriculum. So just, I guess, dig a little bit into some of the associations, and if you have to ask somebody in the industry if they have any ideas, you can do that too. So those are some of the avenues that you can pursue.
Yeah, there really are a lot of scholarships out there, but it takes a little effort to dig them up.
Absolutely. So now, as far as what are some of the things that going into an engineering program? What kind of courses can you expect to take going into school?
Well, because of the general education requirements in accredited curricula, most engineering students take a pretty similar program for the first year or two if they're in a four-year baccalaureate program. So technically that would be a number of mathematics courses, some chemistry, some physics, some general education on the liberal arts side, courses in English and in speech communications and that sort of thing. So that's all sort of the common core of any engineering curriculum, and then you build on that depending on what the major is.
Okay. So now you've found your engineering program, you've gone to school, you've taken some preliminary courses. Now obviously there's a decision to be made as far as what kind of avenue that you want to go down. You can go down and I just kind of want to talk about three different ones here. And there is the very basic mechanical engineering degree, which is kind of, is very often found out there. There is a degree that, frankly, until, what was it, like 2 years ago, I didn't even know existed, the mechanical engineering technology degree. And obviously there is a rare degree that actually is part of your program, which is the architectural engineering degree. Can you give me a quick overview of, there's a lot of choices there. How do you know which to pick?
Well, mechanical engineering, for someone who wants, let's say, a career as a professional, is the standard degree. It emphasizes fundamentals, basic engineering sciences and basic engineering procedures, but doesn't really slant graduates terribly strongly in one direction or another in terms of profession. You can go through a mechanical engineering curriculum and you'll take a lot of thermal science courses, fluid mechanics, thermodynamics, heat transfer. There might be one or two HVAC courses that you could take as an undergraduate, but that's it. So you come out of that kind of curriculum with a very strong background on which you can build all sorts of careers, but not a lot of professional training. So that's what it does. The technology degrees are focused more on people who want to perhaps go into careers like being installers, technicians, do maintenance, although you can become a designer through those sorts of programs too. A lot of technology degrees are two-year associate's degrees, but some of them, Ferris State, Penn College, and a lot of others can be four-year degrees. You add on another couple of years and get a bachelor's degree. So they tend to be more focused on hands-on sorts of things and have more of that practical component. Architectural engineering is a professional type of program. So you have a core that is the same core that other engineering disciplines take, but you have a lot more specific education related to the building industry. And for that reason, it's often a longer curriculum. There's a lot of diversity in architectural engineering programs. Some of them are 4 years, some of them are 5 years, and they don't all offer exactly the same options. Penn State's a 5-year program, and you can specialize in any of 4 different areas here: mechanical systems, lighting and electrical systems, structures, and construction management. So in our curriculum, everybody does the same thing up to the 3rd year, and then they pick one of those 4 and concentrate on it for the last 2 years. So they come out with a great deal more preparation to work in the building industry.
Now, because when I think of architectural engineering, obviously you put architecture right up front. It really doesn't necessarily have anything. Do you have architects taking the architectural engineering core courses?
We offer some courses to architecture students, and the architecture faculty teaches some of ours. It's an interesting and maybe a little known fact that the architecture department at Penn State was spun off of the architectural engineering department, which is maybe not the normal thing. So we have a separate Department of Architecture and a Department of Landscape Architecture that are in the College of Arts and Architecture, and architectural engineering is in the College of Engineering. So we have a lot of cross-pollination, I guess you'd say, but architecture students are in that program and engineering students are in ours.
So now, how many, when we're talking about, there's a number of universities across the United States. Architectural engineering, how easy is it to find a architectural engineering program? I mean, obviously, I think that yours is a rather old one. If not, I don't know if not the oldest. I don't know how common it is. Do you have any idea?
There are around 20 accredited programs now, and then they've been around for over 100 years in the case of Penn State, and others have just been started up within the last year or two, like in Missouri. There's a brand new program, and Illinois Institute of Technology started one recently. The accreditation of architectural engineering programs has American Society of Civil Engineers as the lead organization, and AE is mainly associated with civil engineering, at least at this point. So within ASCE, there's an Architectural Engineering Institute, AEI, and they maintain lists of programs. So if you go to the ASCE website and look them up, you can find information on the programs that are available in the U.S. There aren't that many of them, and they're scattered around.
Okay, great. And I will put just so people don't have to remember all that, I will put a link in the show notes. If you go to buildingx.co, I will put that in the show notes for this episode. So I guess, when you make a decision, whether or not it's mechanical engineering, architectural engineering, engineering technology, is there a tendency to switch? Like, they go into mechanical engineering and they say, I really like that architectural engineering. Is there switching that goes on, a lot of switching that goes on, or is it pretty much, people tend to stick with a program once they've committed to it?
Depends on which way you're talking about going. Architectural engineering at Penn State takes students in at the end of the first year, where other majors like mechanical engineering don't actually have formal admission to the major until the end of the second year. And we have a very tightly structured curriculum, and we also have an enrollment limit that we hit pretty much every year. So generally speaking, we don't take anybody in who didn't come into the program through the front door, through the regular first year or second year entrance to major. We don't have people coming over in the third or fourth year. If you were in mechanical engineering, yes, you could switch to different majors pretty easily at a variety of points in your curriculum. I suppose the same is true of technology. But students who go into architectural engineering here knew they wanted to do it at least by the end of their first year in college. So they have to have had some previous exposure that made them think that the building industry was where they wanted to be. And we tend to keep them, too. We have a very high retention rate. We graduate pretty much everyone who we admit.
Excellent. Now, I guess you talked a little bit about, I guess, what do you see as the primary benefit to getting an architectural engineering degree?
Well, I think probably the best thing about it is that all of our students come out understanding not just their specialty, but also the other engineered systems of the building and architecture. I would say if we just wanted to compare mechanical skills of a mechanical option graduate from architectural engineering and someone who got a mechanical engineering degree, over time, I think that any differences at the outset would go away. But I don't know that a mechanical engineering student can ever pick up the broad knowledge of the whole construction process that an architectural engineering student has. To be a mechanical student and have taken nearly as many structural courses as a structural engineer, to have had courses in project management and acoustics and in lighting. I think it's that broad background that is really valuable, and it's why architectural engineering students tend to always get jobs coming out of school regardless of the job market, because they're sort of ready to go as entry-level employees, and that's perceived by employers to be a big advantage.
Right. So it's almost like a apprenticeship almost, if you kind of think of it in a sort of way, that they've already had, they've already been geared towards that certain profession, so they really have a lot of the skills that profession would be looking for.
They're familiar with the kinds of calculation techniques that are actually used in the industry. They've studied codes and standards in their classes, and they've probably had some summer job experiences directly in industry. So they're quite well prepared to start working.
Now, there's been a lot of changes in the HVAC industry as of late, as pretty much the whole. I wouldn't say just HVAC, but what sort of changes as far as coursework do you see that are going on in the architectural engineering program? What sort of new courses are coming on board?
I think probably the strongest trend that we're seeing now is a lot more emphasis on integrated design and how we do that. So where we've had a Capstone project here at Penn State for many years, it was an individual project. In the last few years, we have been taking some of the students and have them do what we call a BIM project, where they work in teams, students from the different options on the same building in their project. So I think that's maybe the biggest thing is trying to work BIM and those tools into the curriculum and to promote working in teams in collaborative integrated design.
Now, is that the Capstone project that you're referring to, that's similar to like a senior design project?
Yes, it's a year-long project in our curriculum. Others may only have one semester, and others do it as a team thing. What our students do is during the summer before their final year, they get design documents for a building that's either recently constructed or in construction. So they get the drawings and the specs from the designer or owner. And in the fall semester, they do a lot of analysis on the building. So if you're in the mechanical option, you would do a standard 62.1 ventilation analysis for the building, and you would do your own load and energy calculations and do an evaluation report on all the building's mechanical systems. And then the first semester ends with development of a proposal for a redesign project. And the redesign includes a mechanical depth component that emphasizes their option, and also some breadth components where they'll work on other systems and hopefully integrate that with their depth project. And in the spring, they carry that out and prepare a report and a presentation, and every student presents to a faculty jury about 3 weeks before the end of the semester. And from that group, a small group of students who have the best projects get picked to present to an external jury, and then there's some awards at the end of the semester. So it's a very big deal for the students that keeps them busy all year, and is something that they all look back on as maybe one of the high points of their education here.
Oh, excellent. Now, as far as a lot of engineering programs will have a component, or at least it'll be part of the school, that they'll have a cooperative education, a program there, a co-op program where they can go out and work for maybe a semester in a summer, or maybe it's just a summer, but there's a co-op program that's integrated into the curriculum that students can opt into as a way to kind of gain some real-world work experience prior to graduating. Now, is that something that's something that is integrated into the architectural engineering program as well, or?
We don't have a formal co-op program that we encourage our students to go into. There's a college co-op program that we've had a few participate in over the years, but the issue with the co-op program is it adds a year to the length of your degree, and ours is already 5 years long. So if you go back to the issue of costs, if you're going to have to pay for 6 years of school, that really is a big financial burden. But our students are generally able to get summer jobs after their second year. So after second, third, fourth year, they can get a summer job with a company in the industry, and that provides a lot of experience. And in fact, a lot of those students wind up working for their summer employers, and some of them do part-time work when they're at school because it's now possible to do essentially telecommuting. So we don't have a co-op program really because we don't need one. Our department has its own career fair every year. We have that usually in the fall, and we typically get 120, 130 companies in to interview our students. That's significant because we only graduate about 100 a year. So those companies that are here are not all going to get students, and in HVAC we only have about 20 graduates. So what they're looking for is not just permanent employees, but they're here making summer hires because they can use those students and because it's a way of pre-recruiting them for permanent jobs. So that's how we handle it. There are other schools that actually have a required work segment built in.
Now, as far as if you're thinking about a 4-year mechanical engineering degree, a co-op would be a good program to get into if you can swing it.
Yes, absolutely. That's something that's lacking in a traditional 4-year curriculum, is the opportunity to get that practical experience.
So now, once you've graduated, or around the time you graduated, you have the opportunity to typically, as an engineer, to take in the U.S. again, to take the engineering training exam. What's your opinion of the EIT, as they call it?
Well, I think it's good to do that and to promote licensure. It's been an awful long time since I took it, but we encourage our students here to do that and to be in a position to complete their registration if they go in a direction in their career where that's going to be helpful.
Now, I guess let's see. I've always taken an opinion that I've run into so many engineers who didn't take it that are just kicking themselves afterwards, because it is one of those things that while you're in school, you're in that study mode. You don't really have distractions or obligations that really hold you down. And a lot of what the first exam, because it's a 2-part exam, the second part comes 4 years after you've had some experience, but the first part really is something that, excuse me, has a more technical, course focus. There's a lot more number crunching, and it has a lot to do more with theory than it does with practical application, which is more kind of where the second one is geared at. So I was
yes, it's much broader. I think that's the thing, is that when you're out practicing for a few years, you're going to focus on a subset of those things that you learned in your university education. So it becomes very hard to pull that stuff up again to take the exam if you wait.
Now, getting out into the job market, obviously, what do typical engineers? Obviously, the students that you teach really don't have, too much of a problem finding a job. Maybe not necessarily finding the right job, but finding a job they can do that pretty easily. What do typically, what engineers, what are some of the things that they should focus on or expect really when they get out in the job market? Are there any sort of preconceived notions that they're going to get a job that pays six figures or anything like that?
Well, I think our students probably have a pretty good idea of what kind of pay they're going to get, which is pretty good for a starting salary. I think the big question is, what are they going to ask me to do, and am I able to do it? And I think the tendency is to take entry-level engineers and put them on things like doing calculations, because they tend to have better computer skills than the older engineers in a lot of companies. So you wind up turning the crank on the load calculations and the energy. So that is something that you might expect. I think in terms of what to look for, if I'm talking with our students about what should they be looking for an employer, I'd be suggesting they look for someone who's not going to pigeonhole them and just have them doing the same thing over and over, but has a program for developing new employees to move them around to experience different parts of the business, and in our business especially, to get them out in the field and to see systems being constructed and to do field work on buildings that are being renovated and that sort of thing. You want to get a broad experience, because the chances are your first job is only going to last for a few years. That the typical worker these days has quite a few jobs over the course of a career. So maybe that's another principle, is don't expect your first job to be perfect. Don't be so particular about it, because it's likely not to be your last.
Now, in the job market, obviously, once you've graduated from college, I think, especially with HVAC, there's a critical component with continuing education. I guess, what would your recommendations be out in the job market for, updating your skills or keeping your skills, or, any tips there, how best to do that?
Well, there's certainly lots of continuing education opportunities available today. You can get some credit for going to meetings that are put on by professional societies. Some ASHRAE chapter presentations, for example, would have PDHs with them. Organizations like ASHRAE produce a lot of courses they could take online at home that would be a way that you could update your skills without having to travel. And of course, there's some of the traditional options, places like the University of Wisconsin that teaches a lot of instructor-led courses on site and remotely. So there are lots of opportunities out there, but it is an investment of time and money to do it.
Okay. So if anybody, I guess that pretty much covers all the things. Any sort of additional things that you wanted to add? Anything that you think that we missed?
I think we've covered it pretty well. Maybe the closing comment is that I'm concerned that relative to our profession, there aren't that many places where you can go for a really solid introduction to HVAC. Being a mechanical engineer myself, I think I was prepared well on fundamentals, but I really learned very little about the construction industry and about HVAC from the curriculum that I had, and I hope that over time we can perhaps improve the availability of HVAC education in mechanical engineering curricula.
Okay. So if somebody wanted to get a hold of you, what's the best way to do that?
Email works great for me, wbahnfleth@psu.edu.
Okay. And I will post that information as well on the show notes. Well, I appreciate all your time, Bill, and I wish you good luck in your teaching and to all your students. So I appreciate you being on the show.
It's been a pleasure talking with you.
And we're back. All right. A really great and sincere thank you to Bill Bahnfleth, who's a professor at Penn State. and for giving his time to talk with us and kind of give us some great information as far as engineering, what people should look for, and really kind of just different degrees that you could possibly get. I really like that architectural engineering degree. As most of you who have heard some of the past episodes, when I went into engineering, part of the reason is I used to watch This Old House on every week, and I thought it was great. Just you couldn't get enough of the construction industry, but I didn't necessarily know. I said, okay, well, I'm good in math. I should be an engineer because that's kind of like what they do. But I didn't necessarily know that this field was out here. So, really, I wanted to be able to highlight the fact that there is an architectural engineering degree that's specifically geared towards this profession. And as Bill pointed out, I mean, they really do prepare students well for this profession. Which is very rare, and again, I kind of do this at HVAC 360 just to supplement, people going to college. Some people don't necessarily have the opportunity of having an architectural engineering degree in their backyard, so I'm kind of the supplement to that. That's at least that's my feeling, or my hope, I should say. All right, well, I appreciate everyone listening. It's very exciting to be able to do this week after week. I really appreciate all the people who listen. Each and every one of you are very special to me. So thank you. If you want to share this, if this has been valuable to you, if you know somebody who is looking to get into engineering, maybe you can kind of pass this along as something that they might want to look at to kind of give them a little bit of background that they can spend a half an hour and listen to some of the explanations that we have. And maybe it can kind of, give them an idea of, okay, maybe this is something I want to go into, or maybe it's something I don't want to go into, but just to be educated and make the right choice. So pass it along to them. If you know somebody else who's consulting, consulting youth, pass this along to them as well. Just forward them a link, or tell them to look it up on iTunes. However you're finding this is fine with me. I'd appreciate that. All right. If you want to get a hold of me, you can get me on. You can either send me an email directly, matt@buildingx.co, or you can follow my Twitter stream at buildingx. And lastly, you can find me on LinkedIn. So just look for me on LinkedIn and shoot me a contact, and I'd be glad to connect with you. So I guess that's pretty much all for this week. You take care, stay safe, and remember, know what you build and share what you know.